I'm Justine Murphy with Vision Systems Design's Focus on Vision. There are a lot of exciting things happening in machine vision and imaging. Let's take a look. Researchers in the School of Advanced Science and Engineering at Hiroshima University in Japan have developed a machine vision platform capable of visualizing vibrations in moving parts. The system is designed to replace existing approaches to monitoring vibrations, an important process used to identify potential failure points in industrial machinery and civil infrastructure like bridges. The new system features an industrial microtron camera that captures grayscale images of vibrating objects at a rate of 1,000 frames per second. A parallelized algorithm is used to calculate displacement measurements across the entire surface of an object. To verify the system's effectiveness, 2 sets of tests were conducted that documented vibration frequencies of an oscillating cymbal and a steel box. In the first test, a metal cymbal was observed as it freely vibrated after being struck with a wooden stick. For the second test, an industrial steel box was forcibly vibrated by setting it on a vibration testing machine. In both tests, the vibration visualization system accurately estimated full-field vibration responses at different levels of frequencies, demonstrating results similar to traditional methods. Vision Systems Design's Virtual Machine Vision Summit is right around the corner. The 2-day event, scheduled for September 9th and 10th, will feature many presentations on the latest innovations in the industry. Among them will be 3 keynotes that you don't want to miss. These include a panel discussion with Ronald Mueller and Mark Williamson from machine vision consulting firm Vision Markets. They'll discuss how to succeed in the current economic climate in the machine vision sector. Zhang Liu, a professor at the University of British Columbia, will explore the machine vision innovation pipeline, from compiling meaningful datasets and developing robust algorithms to deploying interoperable real-world solutions. He'll also focus on how inspection results can inform industrial asset lifecycle management when integrated with standardized frameworks, cloud computing, and industrial IoT platforms. And kicking off the second day of the summit will be Joe Castaneri, Director of Software Engineering at AMP. He'll dive into how the company uses deep learning to identify recyclables and contaminants in real time in both single-stream recycling and municipal solid waste processing. To learn more about the summit, the speakers, and to register, visit the link below. A new system developed by Spanish automation company DGH for a large French auto conglomerate will allow inspection of welded joints between metal parts on automobile body shells. When the inspection station in the system receives a trigger from the PLC, 2D cameras mounted on robotic arms take photos of the welded connections and transmit them via the GigiVision protocol to the machine vision software where they're processed. The development team says the software uses 2 deep learning algorithms to check for cracks, incomplete weld seams, and irregular welding patterns. Designed with software from MV Tech, DGH's analysis starts with instance segmentation, which finds the welded seams in the images. This step is followed by an algorithm designed to detect anomalies in the seams. And based on these results, the system determines whether the weld passes inspection. And that's it for this edition of Focus on Vision. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit vision-systems.com for the most up-to-date, interesting, and exciting news impacting the machine vision and imaging industry.